Hello students and welcome to my channel Maths App. So in the previous videos on curve tracing, I've covered curve tracing in Cartesian coordinates. So today I'll tell you about curve tracing in polar coordinates, right? So we start with the first point, that is symmetry. So now in polar coordinates, we have symmetry about various lines or the angles, right? So we have two things over here. First, let me tell you about that, and then we will start with the symmetry about theta equal to 0 line. Now, whenever we draw any curve on polar system, we have r and we have another dimension known as theta. Now r is the radius. So if I draw a circle, so we will say that r is the radius from the pole. We always call this as the pole or the origin, right? So we will always measure r from the pole or the origin. So this distance would be defined as r, right? And the angle at which r is inclined, that is said to be theta. So this axis, the positive x-axis, will be now called as theta equal to 0 line. The positive y-axis will be now called as theta equal to pi by 2. Then the negative x-axis will be called as theta equal to pi. And this one, that is negative y-axis, will be called as theta equal to 3 pi by 2, right? And when we move back to theta equal to 0, so this line will again become theta equal to 2 pi, right? So now let us understand that how do we check for symmetry about theta equal to 0 line. Now, for theta equal to 0 line, our function is depending upon r and theta. So we just replace theta with minus theta. If the function remains unchanged, then we say that the function or the curve is symmetric about theta equal to 0 line. So let us take an example. So here you can see the shape. You can see this part lying above theta equal to 0 line is similar to what is lying below theta equal to 0 line, right? So this line is theta equal to 0 line. So this curve is symmetric about theta equal to 0. So now let's move on to the second symmetry, that is symmetry about theta equal to pi by 2 line. Now when do we say that a graph or a curve is symmetric about theta equal to pi by 2 line? When we replace theta with pi minus theta, and if we get the same curve, then we say that the function or the curve is symmetrical about theta equal to pi by 2 line. So now here you can see that this line is theta equal to pi by 2, and you can see that the left and the right portions of the function or the curve is almost the same, right? So this theta equal to pi by 2 line is acting as a mirror. So we will replace theta with pi minus theta, right? Now, let us check the symmetry about theta equal to pi by 4 line. Now, when we check for theta equal to pi by 4 line, we will replace theta with pi by 2 minus theta. And how will the graph look like? So you can see that this is theta equal to pi by 4 line, right? And you can see that the left, the yellow lobe, this portion, above theta equal to pi by 4 and below theta equal to pi by 4, they are same. So this line theta equal to pi by 4 is acting as the mirror. Right? Here you can see more symmetry also. You can see that the green portion of the curve is symmetrical about theta equal to 3 pi by 4. This brown portion is symmetrical about theta equal to 5 pi by 4. And the white portion is symmetrical about theta equal to 7 pi by 4. Right? So now let us understand symmetry about theta equal to 3 pi by 4 line. So here we are going to replace theta with 3 pi by 2 minus theta, and I've already shown you the graph. So the green portion of the curve is symmetrical about theta equal to 3 pi by 4, right? So you need to remember that when we replace theta with what parameter, then what symmetry is there, right? Okay. Now let us check, how do we check for symmetry about the pole or the origin, right? For pole or the origin, we simply have to replace r with minus r. Theta will remain same. So if the function remains unchanged, then we say that it is symmetrical about the pole or the origin. So here you can see that this dimension is positive r, right? So if I take a point here, this point will be marked as r comma theta. Theta is the angle measured from here, right? And The graph is symmetrical about the pole because you can also say, like we did in Cartesian system, that if you rotate this slope at an angle of 180 degrees, you should get the same thing, right? So that is what we are getting. So r comma theta reflected around 180 degree will give us minus r comma theta, and hence these two lobes are symmetric about the pole or the origin, right? Okay. So now, apart from symmetry, let us understand that when will the curve pass through the pole or the origin. Now, when we put r equal to 0 in the curve, and if we get real values of theta, then the curve always passes through the pole or the origin, right? So the things are almost similar to what we have done in the Cartesian system. There we were putting x equal to 0 and y equal to 0 in the curve, and if it gets satisfied, we say that the curve passes through the pole or the origin, right? There we don't use the name pole, we use the name origin here, right? But here, most of the times we will be using the name as pole. So how to check whether a curve passes through the pole or not? Just put r equal to 0, and on solving that equation, if we get real values of theta, then 100% the curve will pass through the pole, right? And if putting by r equal to 0, it doesn't give any real values of theta, then the curve will not pass through the pole, right? And how do we check for tangents? All the real values of theta for which r is equal to 0, they will give the tangents at the pole or the origin, right? So all the real values of theta, suppose we have any equation when we put r equal to 0, we solve that equation. So whatever are the real values of theta that we will get, they will give us the tangents at the pole, right? So we have covered symmetry, and we have covered how the curve passes through the pole and how to calculate the tangents at the pole, right? Thank you so much for listening to me, and do subscribe my channel if you haven't subscribed to get the latest updated videos, and believe in yourself and you will definitely do it. Have a nice day.